Good evening, everybody. I am Vishwajit Pal. This is my first YouTube live to you. After several unsuccessful attempts after lockdown of our country. Actually, আমরা কেউই জানি না আগামী দিন কি হতে চলেছে আমাদের সবার কাছে, বা কি দিন আসছে, কি হতে চলেছে। তো আমরা এই মুহূর্তে অনেকটাই আতঙ্কিত, আমরা জানি। প্রেজেন্ট স্ট্যাটিস্টিক্স যা বলছে, confirmed 716, active 658, recovered 45, disease 13. এটা দেখা যাচ্ছে কিনা জানি না। এটা ইন্ডিয়ার এই মুহূর্তে রেকর্ড। যাই হোক, this way to meet with all of you, particularly the current fourth semester student, to share some of our thoughts or ideas with you, basically subject based. I already serve you some problems on multiple integrals today to do yourself in your notebook. Hope you have already done. Actually, my voice is audible or not? It is audible. Okay. Hope you have already done the problems. There are 3 problems particularly. The topic is multiple integral. We have several times discussed about multiple integral or double integral, triple integral, etc. So now I'm not going to define details. Just I want to highlight those tougher problems which frequently we require to take transformation from one coordinate system to another coordinate system in order to simplify the region. Suppose E is our primary region, maybe that is in Cartesian coordinate system. From E to E dash, we are going through some transformation, maybe using polar coordinate system or spherical polar coordinate system, or from Cartesian to another Cartesian, etc. Such that 3 things must hold. Actually, we have already assumed, without proof, we can state that the first partial order derivatives must exist. That is, if we move from xy to uv, del x, del u, del x, del v, del y, del u, del y, del v, etc. must exist, number 1. Number 2, the Jacobian, you know what Jacobian is? The sub-Jacobian must be fixed. And number 3, there must be a one-to-one correspondence between the old region, the points of old regions to the points of new region. There must be one-to-one correspondence. Not only in the points in interior points, the points on the contour or on the boundary. Suppose from E to E dash, there must be a one-to-one correspondence. These 3 things we should keep in our mind. Next, let us come to today's problem. The first problem was triple integral dx dy dz under root 1 minus x square minus y square minus z square. Yes, some students are writing their name and roll number. This is fine to know who are currently are online. First of all, here the integrand was x greater than equal to 0, y greater than equal to 0, z greater than equal to 0, and x square plus z square less than equal to 1. I have several times discussed in the class that this is basically the positive octant of a sphere. What is octant? Octant means the 1/8 part of a three-dimensional object. Sphere is a regular three-dimensional object. X greater than equal to 0, y greater than equal to 0, z greater than equal to 0 means where all the coordinates are positive. All the coordinates are positive. This will happen if all x, y, z are in a particular octant. This is what we call the positive octant. You know, the 1/8 of a sphere. So first what we do, we here take a transformation from xyz to r theta phi, the spherical polar coordinate system. You know the transformation: x is equal to r cos theta sin phi, y is equal to r cos theta cos phi, and z is equal to r sin theta. Under this transformation, we know the Jacobian, the value of Jacobian is r square sin theta. So our transformed integral will be something like that. I have given one hint. The transformed integral can be separable r in terms of r, theta, and phi. R square here divided by root over of 1 minus r square. R varies from 0 to 1. Since this is positive octant, if I get opportunity, I will show what positive octant is. Several times I ask you to think by closing your eyes what is the positive octant of a sphere. In positive octant, we know theta varies from 0 to pi by 2, phi also varies from 0 to pi by 2. As here r, theta, phi all are separable, the integration, we have three separate integration. R is equal to 0 to 1 r square here divided by root over of 1 minus r square. It will give the answer pi by 4. In multiplied by sine theta 0 to pi by 2 d theta, it will give 1. Multiplied by d phi, pi is equal to 0 to pi by 2, it will be pi by 2. So pi by 2 into 1 into pi by 4. So the final answer is pi square by 8. Hope you have done this. Next problem is a double integral over E, where E is a circle, x square plus y square minus 2ax is equal to 0. As you know, in the diagram I provided morning, this is a circle whose center is at a0 and which touches y-axis at the origin. So if you see the figure which I provided in the morning, by taking transformation x is equal to r cos theta and y is equal to r sin theta, the circle will become r square cos square theta plus r square sin square theta minus 2a r cos theta equal to 0. So first two term will give only r square, because r square cos square theta plus r square sin square theta equal to r square. So r square minus 2a r cos theta is equal to 0. So r will get cancelled. Ultimately, we will have r minus 2a cos theta is equal to 0. Therefore, r is equal to 2a cos theta. I think my voice is audible. So r is equal to 2a cos theta. So now you look the figure, the shadow. Here, the range of integration, first of all, Jacobian. Jacobian is standard. The value of Jacobian will be r, simply r, because x y to r theta, x y x is equal to r cos theta, y is equal to r sin theta. Jacobian will be equal to simply r. So in the transformed region, the integral will become integration the varying limit of r from 0 to 2a cos theta. You see, r is equal to 2a cos theta. Here, the integral has been taken in the upper half of the circle, x square plus y square minus 2ax is equal to 0. So if theta is equal to 0, the varying line OP will coincide with x-axis. So the initial value of theta will be equal to 0. It will not come down the x-axis because we have to consider only the upper half. And if theta increasing, go on increasing, when it will coincide with y-axis, theta will be equal to pi by 2. So the constant limit will be equal to, it will vary from theta is equal to 0 to theta is equal to pi by 2. And for varying limit of r, it will take r is equal to 0 to r is equal to 2a cos theta. So the final integral will be equal to theta is equal to 0 to pi by 2 d theta into r is equal to 0 to twice a cos theta root over of 4a square minus r square, because x square minus y square will be transformed to r square into Jacobian dr. So we have to integrate first root over of 4a square minus r square outside the root into r dr. R is equal to 0 to dr. So whether this is visible to you or not, you see, this is visible. I have already provided you the figure. You can check in your mobile also. So how to perform this integral? I have already told. Take one substitution, 4a square minus r square is equal to t square. Under this substitution, r is equal to 0 to 2a cos theta will be changed to t. T is equal to twice a to twice a sin theta. Not visible, so you listen please. T will vary from 2a to 2a sin theta. So the final integral will be t is equal to 0 twice a to twice a sin theta. Range of t will be twice a to twice a sin theta. And finally, after putting the value of limit, the value of the integration will become 8aq by 3 into 1 minus sin q theta. I repeat, 8aq by 3 into 1 minus sin q theta. So the final integral j will be equal to theta equal to 0 to pi by 2. The value of that integral, just I told, 8aq by 3 into 1 minus sin q theta d theta. So sin q theta I have to put into multiple integral using the formula sin 3 theta is equal to 3 sin theta minus 4 sin q theta. Okay. So after using This trigonometric relation sin 3 theta is equal to 3 sin theta minus 4 sin q theta. The final integrand becomes 8aq by 3 will come outside the integral sign. The limit of integral will be 0 to pi by 2, what it was there initially, and the integrand is 1 minus 3 by 4 sin theta plus 1 by 4 sin 3 theta, which I already provided. Hope you have checked this one, and the final answer will come 4 by 9 aq into 3 pi by 4. So final answer will become 4 aq by 9 into 3 pi minus 4. Please listen carefully. I repeat once again. The final answer 4 aq by 9 into 3 pi minus 4. If I get opportunity, I will show the shape of the octant. You know, the 1/8 part of a regular three-dimensional object is called an octant. Here, in most cases, we will be concerned with the positive octant. Positive octant means where x positive, y positive, and z positive. Three things are there: x, y, z. Each of x, y, z can take either plus or minus. So first place can be filled up by 2 ways. Second place also can be filled up by 2 ways. Third place also can be filled up by 2 ways. So 2 into 2 into 2, there are 8 possible coordinates: plus plus plus, plus minus minus, plus plus minus, plus minus minus, minus minus minus, etc. etc. So plus plus plus, where we find plus plus plus, that is where all the coordinates are positive. We consider this is the positive octant of any three-dimensional regular object. Lastly, we come to the last problem, where it is still a triple integral e to the power square root of x square by a square plus y square by b square plus z square by c square dx dy dz. I repeat, triple integral e to the power under root, everything is above exponential. So e to the power under root of x square by a square plus y square by b square plus z square by c square dx dy dz, where region E is taken here: x square by a square plus y square by b square plus z square by c square less than equal to 1. I think all are present here. You need not worry about present or absent. Rather, you listen in the class properly. So x square by a square plus y square by b square plus z square by c square less than equal to 1. What does it mean? This is basically all the interior points of an ellipsoid. So we have to take here more than one transformation. First, if you can remember properly, from ellipse to circle, suppose x square by a square plus y square by b square is equal to 1. If we consider a transformation x is equal to capital X is equal, sorry, small x is equal to a capital X, small y is equal to b capital Y, it will transform the ellipse to a shorter, relatively easier region. Similarly, here x square by a square plus y square by b square plus z square by c square equal to 1 first will be transformed from an ellipsoid to a sphere by taking transformation small x is equal to a into capital X, small y is equal to b into capital Y, small z is equal to c into capital Z. So it will convert it to the ellipsoid to a sphere. So suitably transforming, we will again consider another transformation. I will take just few minutes more. Another transformation from Cartesian to spherical polar coordinates. Capital X is equal to r cos theta sine phi, capital Y is equal to r sine theta sine phi, and capital Z is equal to r sine theta. Like previous problem, our first problem, the Jacobian will become r square sine theta. So here in this problem, I will check the process, the answer. You do it in your home. I will check in our next class. I have already provided its answer. Its answer is 4 pi ABC into C minus 2. I repeat, 4 pi ABC into C minus 2. So in this particular problem, we have to consider two transformation. That means two Jacobian. First transformation will convert the region from an ellipsoid to a sphere, then from a sphere to relatively easier in spherical polar coordinate system in entire sphere. Okay, so this is basically an experiment. First day, I will trying, rather we will trying to meet you since from lockdown. I don't know whether my voice today is audible or not. I am visible or not, because I am not able to see any of you. I am not able to listen to any of you. Rather, in contrast, you were able to possibly to see me. You were able to listen to me. You will share how is your experience today. Next time I will try to meet you in coming session. Before that, you try to solve yourself the last problem. The answer I have told several times. It is 4 pi ABC into C minus 2. Thank you all. Thank you. Stay home. Stay safe. Thank you.